Hey guys, welcome back. Houston Math Prep here. In this video, we're going to look at some examples of solving absolute value inequalities. Our steps to doing so are pretty much the same as solving absolute value equations. First, we need to isolate the absolute value. Second, we want to split into positive and negative. And third, we want to solve separately. So, looking at our first example here, we have the absolute value of 3x is less than 2. Our absolute value in this case is already isolated, meaning it's already on one side of the inequality by itself. So we'll skip straight to step 2, which says that we should split into both the positive and the negative versions. So splitting here, this is going to become 3x is less than 2. And when we split into the negative, so 3x and negative 2, because we're working with an inequality, remember that means we need to flip the direction of the symbol. So our second inequality is 3x is greater than negative 2. Now solving each one of those, I'm going to divide both sides by 3. So I have x is less than 2/3. And dividing the second one by 3, x is greater than negative 2/3. Next, I'm going to graph both of those on the same number line, making sure that I'm putting my two values that I'm going to be working with in correct numerical order. So in this case, making sure the negative 2/3 is on the left and 2/3 is on the right. And then I'm going to shade. So if x is less than 2/3, less than means I'm going to shade to the left of 2/3. So shading from 2/3 on down. And if x is greater than negative 2/3, I'm going to be shading above or to the right. So above negative 2/3. So in this instance, we can see that we have overlapping shaded regions. Now both of these are strictly less than, greater than, so these are both going to be open circles. And our actual solution region is going to be right here in the middle, the overlapping region. So this is actually an AND problem. Okay, so that means that our interval notation will be from negative 2/3 to 2/3, negative 2/3 to 2/3, and since both have open circles, both get parentheses. Okay, let's look at another example. Here's our next example. Absolute value of x minus 2 plus 2 is greater than or equal to 3. So in this case, our absolute value is not currently isolated. So we'll start by subtracting 2 from both sides to make the absolute value of x minus 2 alone on one side of the inequality. So we get absolute value of x minus 2 is greater than or equal to 1. Now that that absolute value is isolated, we'll go ahead and split into our positive and negative versions. So the positive version will be x minus 2 is greater than or equal to 1. And our negative version will be x minus 2, flip the sign, is less than or equal to negative 1. Now solving each of those, I will add 2 to both sides so that my first inequality says x is greater than or equal to 3. Moving to my second, adding 2 to both sides, I have x is less than or equal to 1. Now, to figure out if we're working with an AND or an OR, we want to go ahead and graph that on the same number line. So 1 and 3, 1 is less than 3, so it needs to be to the left. And now we'll work on shading. So if x is greater than or equal to 3, greater than means to the right. So I'm going to shade to the right of 3. X is less than or equal to 1. I'm going to shade to the left, left for less than, and that gives me 2 non-overlapping intervals. Now both of these have that or equal to symbol, so 1 and 3 are both going to get a filled in or closed dot. Because I have non-overlapping intervals, this is an OR type solution. We have 2 regions that our solution can be in. And so using our knowledge of inequalities and interval notation, we can write our solutions as -infinity to +1, or +3, again using a bracket, up to +infinity. All right, guys, that does it for this video. See you in the next one.